Hey Chantal, we can certainly take a look at this one, friend. Now this one, ton of information. This is a complex fraction, right? And it's called that because we have a fraction where the numerator or denominator are fractions themselves. So a cool way to rewrite this, I think, just for me anyway, is I would write it like this. I would write 4 over x plus h squared minus 4 over x squared, divide sign by h. So I'm taking out this right here, this huge divide sign, and I'm just going to put it old school. And basically for me, again, you don't have to really write this, but you can just visualize that. We're going to work up here in the numerator first, but then later on, I know basically down the road, I'm going to change that to a division sign, and I'm going to flip this fraction, right? So that's going to be like 1 over h. I just know that. So we'll keep that kind of on the back burner for now, and we'll work in here. Now, we have two different species of numbers. Remember, the quick and dirty way to get a GCF is to simply just multiply them together. So our common denominator here, I said GCF, but I meant LCD, sorry, our lowest common denominator. We're just going to multiply these together. So I know I'm going to have two fractions with the denominator of x squared times x plus h squared. Right? So I have that minus my second one, x squared times x plus h quantity squared. Now, because I multiplied the denominators to come up with our common denominator, I can simply cross multiply to create my equivalent numerators. So 4 times x squared is going to go right here. This is going to be 4x squared. And similarly, we can cross this down. This is going to be, now I put the negative in already, so I'm not really going to mess with that negative. I'm just going to multiply this part out here. So this is going to be 4 times x plus h squared. And I'm just going to keep everything factored, everything in brackets for now. Now our next step, we're going to distribute over here. We have to, right? We have to distribute that, and then we'll combine all of our like terms on the numerator. So we can go ahead and do that. Now keep in mind when I distribute, I'm going to FOIL this first because we have to deal with exponents before we multiply. Okay, so let's do that. So my next line is going to be 4x squared, which is this species right here, minus 4 times, and I'm going to just FOIL this out. Now remember, this is x plus h times x plus h, and we're going to FOIL that, right? First, outside, inside, and last. So our first is going to be x squared plus 2xh. I'm just combining the outside and inside because we're going to have xh and then xh, and add them together is 2xh plus h squared. Now all of that is going to be over our common denominator, x squared times x plus h quantity squared. Now remember, again, when we add or subtract fractions, we have to have common denominators, which we do, but then when we do that, we don't really mess with the denominators. So for that reason, I'm just putting all of this numerator stuff over that common denominator. We can do that, I'm not wrong, and it just saves me from writing it twice. Now let's distribute the negative 4, don't miss your negatives. So I'll distribute that across there, like so, and I'll just write what we have left. So we're going to have 4x squared, this is just in the numerator. Now I'm going to distribute, that's going to be minus 4x squared, so that's a cancel. Then I'm going to have negative 4 times positive 2, which is going to be negative 8xh, not plus, minus 4h squared. Okay, and all of that is over our common denominator, x squared times x plus h quantity squared. So what can we do now? Well, 4x squared minus 4x squared is gone. That's awesome. And well, I'll just clean this up and write what we have left. So up top we have negative 8xh minus 4h squared all over x squared times x plus h quantity squared. All right, so now what can we do? Well, we have some GCFs here, right? We have negative 4, and we also have an h, which is common in here as well. So I mean, we could factor that out. We could see if we could cancel something like that. That might be cool. And the reason why I'm going to factor out the h, because remember, I'm still multiplying this by 1 over h, right? I didn't carry that down, but I didn't forget about it. So if up here I can factor out an h, I can cancel that h out and we can simplify this. So let's do that. There's no real point in factoring out the negative 8 and the negative 4 at this point because there's nothing that's going to cancel anyway. I'll just factor out the h from the top. So h, I'm going to start my bracket, and remember, if I mentally divide each term by h, that's what I'm going to put in my bracket. So this is going to be negative 8x minus 4h. right? Dividing by h will get rid of that square, like so. So all of this is still over my common denominator, x squared times x plus h quantity squared times 1 over h. And now we can cancel out our h's. I have an h and an h. Remember, before we cancel stuff, we have to factor, right? When we cancel, we're really dividing. So I can't just go to town and start wiping stuff out. I have to factor first. Now let's do the top. We have negative 8x minus 4h times 1, which is essentially what we had, right? Negative 8x minus 4h. I don't need brackets up here anymore because I've gotten rid of that h that has been canceled, over our common denominator, x squared times x plus h. Now again, you could FOIL this out and, you know, multiply x squared by everything there, but it doesn't really matter. I think this is probably going to be as far as we can go. There's no number down here, so factoring out the negative 8 and the negative 4, there's no x in both terms, there's no h in both terms, so I would say that is pretty much where we're going to go. Now keep in mind this is a rational expression, so we have to specify our variables, right? X can't be 0, that sort of thing. But yeah, that should be it, buddy. So give that a shot. Let me know how you make out.